Hello. Good afternoon, students. How are you? Hmm? आ गए सब लोग? यस और नो? मेरी आवाज आ रही क्या आपको? पहले तो ये बोलो। ओके, अंजस, श्रुति, आकांक्षा, चैतन्य, शालू। ओके, वेरी गुड. चलो. So we will start our lecture. Chaitanya is saying yes, sir. Okay, good. Okay, Arju, Pramodini, Omkar, Raj is saying Hanji. Okay, good. So we will start today's lecture. In the last lecture, we have seen theory of indicator. In the last lecture, we have seen theory of indicator. Why the particular indicator shows color change. So it depends upon the which form of indicator. For example, acidic form is there, that is called as a molecular form, and in basic form, what happens? The H plus ions will goes out and it will give you ionized form in basic medium. Okay, so this acid form and base form, they will have a different color. For example, if you talk about phenolphthalein in basic medium, it is colorless. That we have seen. Phenolphthalein in basic medium is colorless. Okay, but in sorry, phenolphthalein in acidic medium, it is colorless. Sorry, phenolphthalein in acidic medium is colorless. Okay, and in basic medium, that is called as ionized form, it shows a pink color. So it depends upon the which form is present in that particular media that we have seen. Then उसके पहले हम लोगों ने देखा था प्राइमरी स्टैंडर्ड सब्सटेंसेस एंड सेकेंडरी स्टैंडर्ड सब्सटेंस. ठीक है, देखा था कि नहीं देखा था? यस और नो? देखा था ना? ओके, गुड. देन द प्राइमरी स्टैंडर्ड सब्सटेंसेस के हम लोगों ने डेफिनेशन भी देखिए. व्हाट इज प्राइमरी स्टैंडर्ड सब्सटेंसेस? प्राइमरी स्टैंडर्ड सब्सटेंसेस आर दो सब्सटेंसेस व्हिच आर अवेलेबल इन प्योर फॉर्म और स्टेट, which is available in pure form or state, and they are used to standardize the secondary standard substances. They are used to standardize secondary standard substances. In another way, we can say that the primary standard substances are those substances which do not change their concentration. Primary standard substances are those substances which do not change their concentration upon exposure to the environmental factor. Now which environmental factor? For example, heat is there, air is there, light is there, gases are there, moisture are there. So these environmental factor will does not affect the concentration of the primary standard substances. Okay, and these primary standard substances are used to standardize the secondary standard substances. Standardize means to know the exact concentration, Okay, now secondary standard substances generally it is not available in pure form or state, and it is generally the concentration of secondary standard substances are being determined against titrating against primary standard substances. Okay, and in another word we can say that primary standard substances are those secondary standard substances are those substances which changes their concentration upon exposure to the environmental factor. Light, heat, air, moisture, different gases are there. ठीक है, so secondary standard substances के जो कुछ भी concentration है वो concentration change हो जाता है after exposing to the environmental factor or after keeping that substance or that solutions for a long time. ठीक है, so that we have seen in the last lecture. Today we will see the neutralization curve. What is neutralization curve? What is the definition of neutralization curve? Then we will see the end point, we will see equivalence point, we will see neutralization point, we will see. Then we will see the choice of indicator, which is the best indicator, which is suitable indicator, how it depends, what is the indicator range, in which indicator range we have to use which indicator, that we will see in today's lectures. Okay, so ठीक है, can I start lecture? Now you can hear me. Now you can hear me. Tell me. अब आवाज आ रही है क्या मेरी? ओके गुड. Okay, so first of all we will see the neutralization curve. क्या देखेंगे हम लोग? We will see the neutralization curve, the definition of neutralization curve. ठीक है, so we will start with definition. So this is the definition of neutralization curve. Neutralization curve is a plot of change in concentration of H plus ion. It is a plot of change in concentration of H plus ions or pH. It is a plot of change in H plus ion or change in pH as a function of ml of titrant added. This ml of titrant means the burette solution. ml of titrant means it is a burette solution added is known as a neutralization curve or titration curve. This neutralization curve it is also called as a titration curve. Please remember it is called as a neutralization curve or it may called as a titration curve. What is the definition? It is a plot of a change in concentration of H plus ion or pH. It is a plot of change in concentration of H plus ions or pH as a function of ml of titratant added, which is a burette solution, is known as a neutralization curve. So this concentration of H plus ion, this concentration of H plus ion and pH, they are in y-axis. They are in y-axis, and this ml of titrant added, it is in x-axis. So this curve is called as a neutralization curve. Which curve? If you plot the concentration of H plus ion or pH on y-axis and ml of titrant added on the x-axis, then this plot is called as a neutralization curve. This plot is called as a neutralization curve. In the neutralization curve, the H plus ion, the concentration of H plus ion or pH, they are on y-axis, and ml of titrant added, which is a burette solution, it is on x-axis. If this is the case, then that curve or that plot is called as a neutralization curve or titration curve. For example, if you see here, this graph is shown here. In this on y-axis pH is given, on y-axis pH is given, and on x-axis ml of titrant added is given. So this is a plot of this is a titration of HCl 0.1 molar HCl versus 0.1 molar NaOH. So here ml of titrant is here NaOH and titrant is HCl. Titrant is HCl. So this is a plot of pH versus ml of NaOH added. So if you see here, uh, uh, these different indicators are given: phenolphthalein indicator, bromothiamol blue indicator, methyl red indicator, and methyl orange indicator. Okay, and their pH range are given. So this plot is called as a neutralization plot. Sir, this plot is called as a neutralization plot. कैन यू हियर मी? प्लीज टेल मी. मेरी आवाज आ रही है आप लोगों को? अभी किसी की तो कमेंट थी, आई कांट रीड दैट कमेंट प्रॉपरली. कैन यू हियर मी प्रॉपरली? प्लीज टेल मी. Sir, can that curve could be a straight line too? No, that we will see, Raj. That we will see why this curve is not straight line and why it is always in S shape. That we will see. Okay, so don't worry about. Just for this moment. Uh, Hi, Aditi Panalika. Very good, Aditi. Welcome Aditi to my lecture. Thank you. Hi Aditi. Okay, chalo. Then see the plot of change in concentration of pH or H plus ion solution as a function of ml added. It is called as a neutralization curve or titration curve. Now question is why this line is not straight line, that we will see while the chapter is goes to the next point. ठीक है, जैसे जैसे हम लोग आगे आगे जाएंगे तैसे तैसे आप लोगों को ये पता होना चाहिए why the shape is always S shape. ठीक है, why the shape is always S shape. ठीक है, that we will see, don't worry about that. Okay, good. Then the see in this column here some indicators are given. Here some indicators are given. Different indicators are given, and here the values of pH are given. The values of pH are given, and these values are called as a range of that particular indicator. For example, there are different indicators. Sorry, there are different indicators given, but you have to remember only four indicators. फॉर एग्जाम्पल दिस इंडिकेटर यू हैव टू रिमेंबर, मिथिल ऑरेंज. ठीक है, ये आप लोगों को ध्यान में रखना है, द मिथिल ऑरेंज इंडिकेटर एंड द पीएच रेंज ऑफ दिस इंडिकेटर. देन यू हैव टू रिमेंबर मिथिल रेड, देन ब्रोमोथाइमोल ब्लू एंड फेनोल्फथैलीन. ये चार इंडिकेटर है ना, ये चार इंडिकेटर आप लोगों को ध्यान में रखने हैं, बिकॉज ये चार इंडिकेटर हम लोग इस चैप्टर में देखने वाले हैं. कौन से है? Methyl orange, methyl red, bromothiamol blue and phenolphthalein. And here if you see here, its color change is given. Its color change is given red and yellow. Then methyl red is red and yellow, bromothiamol blue yellow and purple, and phenolphthalein is colorless to red or pink. ये चार आप लोगों को ध्यान में रखना है. ठीक है, so you please remember these four indicators and their pH range. In what or from this value to this value it can shows its color change. ये आप लोगों को ध्यान में रखने. ओके, गुड. देन ये आप लोग, आपके पास पेन नोटबुक है तो यू कैन राइट डाउन दिस इज वेरी वेरी इंपॉर्टेंट. ये जो चार इंडिकेटर है आप लोगों को ड्यूरिंग दिस चैप्टर ये आप लोगों को यूज करने होंगे. ठीक है, सो फर्स्ट कॉलम इज नेम ऑफ इंडिकेटर इज देयर एंड इन सेकंड कॉलम पीएच रेंज इज गिवन. ठीक है, सो स्टार्ट्स विथ मिथिल ऑरेंज. ये फर्स्ट आप लोगों का इंडिकेटर है, दैट इज मिथिल ऑरेंज एंड इट्स पीएच रेंज इज 3.1 to 4.4. दैट मीन्स from this pH, that is 3.1 to 4.4, this methyl orange can show a change in color. That means what? That means from this pH 3.1 to 4.4, this methyl orange indicator can show a change in color. ठीक है, so this is its pH range, that is 3.1 to 4.4 methyl orange. Then methyl red की कितनी है pH range? It is from 4.2 to 6.3. It is from 4.2 to 6.3. Then third one is bromothiamol blue. Its pH range is 6.0 to 7.6. 6.0 to 7.6. And phenolphthalein indicator, which is very popular indicator, phenolphthalein. Its pH range, please remember this range, 8.3 to 10. 8.3 to 10. That means this phenolphthalein shows a change in color in basic medium. ठीक है, after 7 the basic medium starts. So 8.3 to 10 means it is basic medium. This is near the slightly acidic or near the neutral, and these two are for acidic pH range. ठीक है, so ये चार आप लोगों को ध्यान में रखने हैं. आपके पास पेन नोटबुक है तो राइट डाउन, और if you don't have pen notebook you take a screenshot. ठीक है, चलो जल्दी से ले लो. 1 2 3 ले लिया स्क्रीनशॉट. ओके, गुड. देन वी विल सी द नेक्स्ट टर्म, दैट इज एंड पॉइंट. व्हाट इज द एंड पॉइंट ऑफ टाइट्रेशन? ये हम लोग देखने वाले हैं. इफ यू आर डूइंग द टाइट्रेशन देयर हैज टू बी सम एंड पॉइंट, और व्हाट इज दैट एंड पॉइंट? दैट वी विल सी. Okay, the definition of endpoint. It is a point. First of all, endpoint, it is a point at which indicator changes its color during the titration. The point at which what indicator changes its color during the titration is called as a end point of titration. As soon as you see the change in color, so you can conclude that your titration has reached to the completion. ठीक है, और वो end point आ गया आपके titration का. Which point? End point. At which point the point at which indicator shows its color change during the titration. For example, if you will see, this curve is there, this curve is there, ये आप लोगों ने पहले भी देखी है. So in this y axis pH is given, x axis ml of titrant added, that is ml of NaOH added is given, and as we are adding the ml of NaOH solutions, what happens, the pH is goes on increasing. At first the pH is 1 and as soon as आप जैसे जैसे आप लोग NaOH ऐड करने जा रहे हो, वैसे वैसे क्या हो जाएगा, आपका pH इंक्रीज हो जाएगा, आपका pH increase हो जाएगा. And from this point, that is from 24.8 to 24.9, this pH get suddenly increase, this pH will get suddenly increase, and after some addition of NaOH, again it will start constant, ये constant हो जाएगा. So this shape is called as a AF shape. So here end point of the titration is कौन सा है बोलो आप लोगों को, this one. What is the value of end point of the titration in this figure, बोलो, what is the value of end point, what is the volume of end point in this figure of the titration, anybody knows, बोलो मुझे, क्या हो सकती है वैल्यू एंड पॉइंट की इन दिस फिगर. So from, see here, from where the indicator starts showing color change, so near about 25. So correct, Sumit is saying 25. Okay, so from this point, that is 24.9 to 25.9, so that means 25. So value of end point in this figure is 25 ml, 25 ml. ठीक है, okay, good. So this is end point. Then equivalence point. Then next term is equivalence point. Please remember, end point and equivalence point, these 2 points are different things. So how they are different, that we will see, don't worry about that. But please remember this, end point and equivalence point are a different thing. So we will see the equivalence point. Definition of equivalence point. It is the point at which exactly equivalent quantities, it may be gram equivalent or milli equivalent, it may be gram equivalent or milli equivalent of acid and base added to one another in the titration is called as the equivalence point. It is the point at which exactly equivalent quantities of acids and bases are added into the one another. फॉर एग्जाम्पल HCl NaOH का टाइट्रेशन ले लो आप लोग, और उसमें एग्जैक्टली इक्विवेलेंट क्वांटिटीज में आपने HCl डाला है और सेम इक्विवेलेंट क्वांटिटीज में आपने NaOH डाला है. दैट पॉइंट इज कॉल्ड एज ए इक्विवेलेंस पॉइंट. That point is called as a equivalence point. ठीक है, एक बार फिर से देख लो definition of equivalent point. It is the point at which exactly equivalent quantities, may be gram equivalent or milli equivalent of acid and bases are added to one another during the titration is called as a equivalence point of that titration. For example, if you see here 25 ml of, example is 25 ml of 0.1 normal HCl is titrated against 0.1 normal NaOH. So NaOH is base and HCl is acid, and the concentration of HCl and NaOH both are 0.1 normal and 0.1 normal. And HCl हमने कितने लिया है, HCl we have taken, that is 25 ml. So how many milli equivalents of HCl we have added? So how will you calculate milli equivalent? फर्स्ट आप लोगों को तो क्या कैलकुलेट करना है, मिली इक्विवेलेंट कैलकुलेट करना है, मिली इक्विवेलेंट, milli equivalent of HCl. So how will you calculate the milli equivalent of HCl? So concentration into volume. So this is the 0.1 normal is the concentration of HCl and volume is 25 ml. So 0.1 into volume, volume is 25 ml. So sorry, volume is 25 ml. So it will come 2.5. So milli equivalence of HCl is equal to 2.5. So and if you add 2.5 milli equivalent of NaOH, if you add 2.5 milli equivalent of NaOH, at that point it's called as a equivalence point of the titration. That means how much ml you have to add NaOH. NaOH आपको कितना ml डालना पड़ेगा to get 2.5 milli equivalent? Tell me now. 2.5 milli equivalent of NaOH. 2.5 milli equivalent of NaOH. At that point it's called as a equivalence point of the titration. That means how much ml you have to add NaOH. NaOH आपको कितना ml डालना पड़ेगा to get 2.5 milli equivalent? Tell me now. टेल मी 2.5 मिली इक्विवेलेंट ऑफ NaOH डालने के लिए आपको कितना ml NaOH डालना पड़ेगा? So as we will get the 2.5 equivalents of HCl and 2.5 equivalents of NaOH, and at that point it's called as the equivalence point of HCl NaOH titration. तो 2.5 equivalent of NaOH ऐड करने के लिए आपको कितना ml NaOH डालना पड़ेगा? That you have to tell me. ठीक है? So tell me now. How much ml of NaOH you will add to get 22.5? Sandesh is saying 5 ml, Raj is saying 26 ml. करेक्ट राज 25 ml. कितना ml डालना पड़ेगा आप लोगों को? 25 ml of NaOH डालना पड़ेगा. 25 ml of NaOH डालना पड़ेगा. So at this point you can say the equivalent point has been reached. At this point you can say the equivalent point of the titration has been reached. So this equivalent point you can calculate theoretically also. This equivalent point you can calculate theoretically also even without doing the experiment. To calculate equivalence point you need not do, or you don't have to perform a chemical experiment. You can theoretically you can calculate. ठीक है? So how will you calculate? For example we'll एक example देख लेते हैं. For example 10 ml of 0.5 normal HCl. कितना ml है? 10 ml. Volume is 10 ml of 0.5 normal HCl is titrated against 0.5 normal NaOH. Is titrated against 0.5 normal NaOH. So to get the equivalence point, how much ml of NaOH you will add, that you will calculate theoretically also. How will you calculate? So see here, for example this is NaOH versus HCl titration. This is NaOH versus HCl titration. So this N1 is the concentration of NaOH into V1 is the concentration of NaOH, and N2 is the concentration of HCl, and V2 is the concentration of V2 is the volume of HCl. Okay, so what is the concentration of HCl? 0.5 normal. So we will take 0.5 normal into volume is 10 ml. Volume is 10 ml. Here normality, that is concentration of NaOH is given, so it is 0.5. Concentration is 0.5. You have to calculate the volume. How will you calculate? So V1 is equal to 0.5 multiplied by 10 divided by 0.5. So how much it will come? 10 ml. So you can calculate the equivalence point of the experiment theoretically also. No need to perform a chemical experiment. Understood? How will you calculate? By using a simple formula, N1V1 is equal to N2V2. That formula is called as a N1V1 is equal to N2V2. By using this formula, you can calculate the equivalent point of the titration. Understood or not? Tell me. Have you understood it or not? Tell me. किसको किसको समझ में आया? बोलो जल्दी से. चैट सेक्शन में बोलो कि हाँ सर मुझे समझ में आया है. हाउ टू कैलकुलेट थ्योरेटिकली. यस, सुमित, आकांक्षा, 2 ही लोगों को समझ में आया है. प्रमोदिनी सिंह अंडरस्टूड सर. चैतन्य ओके. देन किसको किसको समझ में आया? बोलो जल्दी से. Then we will go to the next point of the today's lecture. Then we will go Sagar, Ajinkya, Omkar, Sabha, then Raj, Nutan, Sandesh, Vidhi, Santosh Hake is there, is saying yes sir, understood. Anjas Thakur, प्राची ने भी हाथ ऊपर किया है अपना, ऐसा करके दिया है. ओके गुड, डोंट वरी. प्राची को भी समझ में आया है. श्रुति, देन ये मैं आप लोगों के नाम क्यों लेता हूँ पता है? क्योंकि जब आप लोग अटेंडेंस लिखते हो ना, तो अटेंडेंस देख के मुझे पता चलता है कि कौन था लेक्चर में कौन नहीं था। तो मैं ये वीडियो रिवाइंड करके चेक करके लेता हूँ कि किसका किसका नाम मैंने लिया था, उन्होंने ही प्रेजेंट लिखा है कि नहीं है, और जिसका नाम नहीं आता ना तो उनको मैं वहां पे एब्सेंट करके रख देता हूँ। ठीक है, आप लोगों को पता नहीं होगा, इसीलिए मैं आप लोगों के नाम लेता हूँ, इसीलिए मैं आप लोगों को बीच बीच में बोलता हूँ कि प्लीज रेज योर हैंड, प्लीज रेज योर हैंड, हु अंडरस्टूड दिस कंसेप्ट और नॉट, दैट इज द रीजन बिहाइंड दिस। ठीक है, ओके गुड, चलो then next point is neutralization point. Next point is what? Neutralization point. We will see the definition of neutralization point. So what is the definition of neutralization point? It is the point at which pH of the solution exactly becomes 7. pH of the solution exactly becomes 7 during the titration is called as a neutralization of that neutralization point of that titration. The point at which pH of the solution or pH of the titration mixture becomes exactly 7 during the titration, that titration is called as a neutralization point of that titration. Okay, that point is called as a neutralization point of that titration. So the note, very important note है, आप लोगों को ये लिख के लेना है. Write down this note which is very very important. I am पे लिख देता हूँ the important note, जो है the लगाने से वो very very important हो गया. ठीक है, so these 3 points, which 3 points? The end point, equivalence point and neutralization points are different. Please remember, they all are not same. They are all different. हर एक का मीनिंग अलग अलग है. The end point is different, equivalence point is different. End point means at the point at which your indicator shows color change, that is called as a end point. Equivalence point means the gram equivalent of acid when becomes equal to when gram equivalent of acid and gram equivalent of base, yeah, if you add into the titration same gram equivalent or same gram equivalent of acid and bases, that point is called as the equivalence point. Neutralization point means that at point at which pH of that solution or titration mixture becomes equals to 7, that point is called as a neutralization point. So these all 3 points, they are different. Please remember this, the end point, equivalence point and neutralization points are different. These points may be or may not be reached at same time. These points, which points? The end point, equivalence point and neutralization point, they may or may not be reached at same time. That means the value of end point, equivalence point and neutralization point is not similar. May or may not be similar. Depend करता है which indicator you are using. किसके ऊपर depend करता है? Which indicator you are using. ठीक है, so these points, end point, equivalence point, neutralization points, they may or may not reach at same time. That means the value of end point, equivalence point and neutralization point will may or may not be the same. ठीक है, okay, then for example we will see, for example this titration is there, HCl NaOH titration, that means acid base titration is there. We will see the example of acid base titration. Acid is HCl and base is NaOH. If you are doing this acid base titration, that is HCl and NaOH titration in presence of bromothiamol blue indicator. So this is the indicator. Bromothiamol blue is a indicator. And if this titration is there and you have used bromothiamol blue as indicator, then the end point, equivalence point and neutralization point will be reached at the same time, this is very very important. That means the value of end point, equivalence point and neutralization point will be same in case of HCl NaOH titration and in presence of bromothiamol blue indicator only. When this value will be same, if you have used bromothiamol blue indicator, then and then only this value of end point, equivalence point and neutralization point will be the same. Okay, okay, then the for example, now in second case the example is same, that is HCl and NaOH example, and if you have used phenolphthalein or methyl orange indicator, now indicator is not bromothiamol blue. Now here indicators are maybe phenolphthalein you have used or maybe methyl orange you have used, then the equivalence point and neutralization point reach at the same time. reach at a same time. That means the value of equivalence point and neutralization point will be the same in case of phenolphthalein indicator and methyl orange indicator, but not end point. So end point will be the different. End point will have a different value than the equivalence point or the neutralization point. ठीक है, समझ में आया सब लोगों को? Okay, then we will go to the next point. Sorry. The next point is suitable indicator. Now come to the indicator. Next point is suitable indicator. We will see the definition of suitable indicator. The indicator which shows a color change during the pH change taking place at a equivalence point. When the indicator is there and that indicator shows a color change and the pH change at the same time, and when that equivalence point, and that point is called as a equivalence point, then we call that indicator as a suitable indicator. When the indicator shows a color change during the pH change taking place at the equivalence point, color change or pH change when takes place at equivalence point, that indicator is called as a suitable indicator. That indicator is called as a suitable indicator. For example, let us take an example again. HCl, which is a strong acid, NaOH, which is a strong base. So this is HCl NaOH titration. It is called as acid based titration, and here pH change at equivalence point is 3 to 4. So during this titration, pH change takes place at this equivalence point is 3 to 4 pH range. Equivalence point of this titration is in the pH range. Equivalence point of this titration, that is HCl NaOH titration, is in the range of 3 to 10. In the range of 3 to 10. That means which indicator is suitable for this titration? Which indicator is suitable for this titration? That we will see. Now see. Here name of indicators are given. And here pH range is given. So methyl orange, it shows 3 to 4.4. Methyl red, it shows 4 to 6.3. Bromothermal blue shows 6 to 7.6, and phenolphthalein will show 8 to 3.10. And our pH range of the titration is 3 to 10. Our pH range is 3 to 10. That means these all indicators are suitable indicator. That means these all indicators are suitable indicator because their color change in the pH range in between 3 to 10. यहाँ से मिथिल ऑरेंज का कितना है, 3 से स्टार्ट होता है और फिनोल्फथालीन का इंडिकेटर का रेंज कहाँ से खत्म होता है, 10 से. So these all indicators are suitable indicators. So we can say these all indicators are suitable indicator for HCl NaOH titration. All indicators are suitable indicator for this HCl NaOH titration. But generally the more widely phenolphthalein is used because it is easily available and color change is clearly visible to us. Because color change is clearly visible to the human eye. That's why the phenolphthalein is widely used for this HCl NaOH titration. But we can use all these four indicators. All these four indicators, they are suitable indicator. ठीक है, समझ में आ रहा है? Okay. At that time, will that blue indicator will show the end equivalence and neutralization point at the same point. Raj, please ask your problem or your doubt at the end of lecture. Okay? Okay. I will give you 5 minutes for that. I always give 5 minutes for your doubts, problems. Okay? Okay. So these all are suitable indicator. These all are suitable indicator for HCl NaOH titration. Then the best indicator we will see. What is the best indicator? The definition of best indicator. What is the definition of best indicator? The indicator which has its transition range around the pH at equivalence point. The pH which has its transition range around the pH at the equivalence point is called as a best indicator. For example, let us take this NaOH and acetic acid. Let us take this NaOH and acetic acid titration. NaOH is a strong base, acetic acid is a weak acid. NaOH is strong base. Here I have written NaOH is a strong base and acetic acid is a weak acid. So this titration, NaOH versus acetic acid titration, it is called as a strong base weak acid titration. It is called as strong base weak acid titration. And the pH at equivalence point is 8.73. And the pH at equivalence point is 8.73. The pH at the equivalence point is 8.73. So now you people tell me which indicator is the best indicator for this titration. This titration means NaOH versus acetic acid titration, and the pH at equivalence point is 8.3. Now you people tell me which is the best indicator. Okay, Istisham is saying phenolphthalein will be used. Correct. Very good. Why phenolphthalein will be used? Tell me, Istisham. Why phenolphthalein is used? Okay, Pramodin is saying phenolphthalein also. Akansha is also saying phenolphthalein. Now, why? That you have to tell. Why phenolphthalein will be the best indicator? All four are suitable indicators. You can use as per your convenience. You can use as per your availability. Okay, but the best indicator among the four is phenolphthalein. Best indicator among the four is phenolphthalein. Okay, Istisham is saying because the pH range is 8.3 to 10. Very good. Very good answer from Istisham. Because of what? Because of the pH range of phenolphthalein is 8.3 to 10. Because of the pH range of phenolphthalein is 8.3 to 10. So this phenolphthalein is the best indicator. Phenolphthalein is the best indicator for about titration. Which titration? For this titration. Weak acid and strong base. That is example of NaOH and acetic acid titration. And the suitable indicators are all suitable. Methyl orange, bromothermal blue, methyl red. Raj is saying because it is greater than 7 and hence basic. Correct. Because of the range of phenolphthalein indicator is basic. कौन सी रेंज होती है बेसिक एंड दिस pH at equivalent point कितना है 8.3 that means it is also basic. That means it is also basic. So the best indicator is phenolphthalein indicator. Okay. So I think today we will stop here. Today we will stop here. The remaining part that we will see in the next lecture. Remaining part that we will see in the next lecture. So someone is asking some doubts during my lecture. So what is that doubt? Please ask now. क्या प्रॉब्लम था? राज था शायद ना. बोलो राज, व्हाट इज द प्रॉब्लम? क्या प्रॉब्लम था? So it's raining outside. हमारे यहाँ बारिश स्टार्ट हो गई है. किसके किसके यहाँ बारिश स्टार्ट हो गई है? If the concentration of the solution is different, if the concentration of solution is different, that means what is your question? I can't understand it. What is your question? If the concentration of the solution is different means what? Yes sir, raining like cats and dogs. Yes. इसलिए शाम के यहाँ पे भी raining हो रही है and then the volume will be the different. Oh, Pramodini, you're saying it's raining sir. Okay, मतलब बारिश is all over the Pune. अजिंक्य के यहाँ भी बारिश हो रही है. Okay, good. Raj, you please ask your question. Write your complete question in Google Classroom, so I can understand your questions completely. Nutan Parab saying it's raining, sir. Shalu is also saying it's raining, sir. Okay, good. So maybe हमारे यहाँ की light जा सकती है. So if light goes, then internet will not be there. That's why I have stopped this lecture. मैंने क्या किया है, जल्दी से लेक्चर यहीं पे स्टार्ट किया. बिकॉज ऑफ व्हाट? बिकॉज ऑफ द इलेक्ट्रिसिटी प्रॉब्लम. ठीक है. आई एम यूजिंग दिस ब्रॉडबैंड एंड इफ लाइट इज नॉट देयर, दिस ब्रॉडबैंड नॉट वर्क. ओंकार दीक्षित इज सेइंग नो. ओंकार तो कहाँ पे रहता है? ओंकार कुठे राहतोस तो? इन पुणे और आउटसाइड पुणे? There is no raining in my village sir. Chaitanya. Okay. तो आप लोग पूना में नहीं हो. Okay. So Raj, you please write your complete question in Google Classroom so I can understand what is your problem and I will answer that question. Raj is saying no sir, here is sunny weather. Okay. I am from AMT. AMT means what? Vidarbha. Chaitanya Chauhan, Vidarbha. Amravati. Raj is Amravati. Okay. Okay, okay, okay. So बहुत से सारे कोने में मेरा लेक्चर चल रहा है. ठीक है, अच्छी बात है. Okay. So shall I stop now? Shall I stop here now? Please tell me. In the next lecture, we will see the some problem also. Okay. Okay. Goodbye. So till then, goodbye. Have a nice day. We will meet in the next Thursday. Maybe next Thursday exams are there. Last year के exams है. So maybe हम लोगों को supervisions भी रहेंगे. So I will inform you if lecture is there. I will inform you one day before. ठीक है? Okay. टिल देन आप लोग पढ़ते रहो. जो कुछ भी पॉइंट आप लोग मेरा समझ में नहीं आया आप लोगों को वो पॉइंट आप लोग मेरा वीडियो रिवाइंड करके भी देख सकते हो. So I am recording the video for you people only and uploading it on YouTube to get your offline exam WhatsApp. नहीं दोनों पे दोनों एग्जाम दोनों मोड भी है. ऑफलाइन मोड इज देयर एंड ऑनलाइन मोड इज देयर. सो बहुत से सारे बच्चे ने ऑफलाइन मोड भी चूज किया है तो हम लोगों को जाना पड़ेगा सुपरविजन के लिए. ठीक है. ओके गो. सो थैंक यू. बाय बाय. channel.